Before finishing this session, I want to make some general remarks about the course. First of all, a few words about background. The course presumes that you are comfortable with symbolic manipulation, as used, for example, in solving high school algebra problems like the one we saw earlier. The course also presumes some basic mathematical background. In particular, it assumes that you understand sets, set operations, such as union and intersection, and set relations, such as membership and subset. And it presumes that you are familiar with functions and relations. However, nothing else is required. If you have this background, you should be fine. If not, you might want to brush up on these things before continuing. Next, a few words about how to proceed through the course. The course consists of these lectures, lecture notes, additional readings, and exercises. All four are useful. While it may be tempting to do so, do not skip the exercises. They reinforce points made in the lectures and the readings, and in some cases they motivate subsequent material. Also, consider taking advantage of communication aids to discuss issues with others taking the course. Post questions that are bothering you, and if you know the answers to questions posted by others, help out by answering. Explaining material to others is one of the best ways of learning a subject. Although logic is a single field, there's more than one logic in this field. In the three main units of this course, we look at three different types of logic, each more sophisticated than the last. Propositional logic is the logic of propositions. Symbols in the language represent conditions in the world, and complex sentences in the language express interrelationships among these conditions. Primary operators are Boolean connectives such as and, or, and not. Relational logic expands upon propositional logic by providing a means for explicitly talking about individual objects and their interrelationships, and not just monolithic conditions. In order to do so, we expand our language to include object constants, function constants, relation constants, variables, quantifiers, and so forth. Epistemic logic goes one step further and provides a means for talking about sentences as objects in their own right, and providing operators for expressing relationships between expressions and other expressions, and relationships between expressions and the things they represent. This extension allows us to encode information about information, and allows us to define the notions of truth and belief within logic itself. Each logic brings new issues and capabilities to light. Despite these differences, there are many commonalities among the logics. In particular, in each case, there is a language with a formal syntax and a precise semantics. There is a notion of logical entailment, and there are legal rules for manipulating expressions in the language. These similarities allow us to compare the various logics and to gain an appreciation of the trade-offs between expressiveness and computational complexity. One final comment. In hopes of preventing difficulties, it's worth pointing out a potential source of confusion. This course exists in the meta world. It contains sentences about sentences. It contains proofs about proofs. In some places, we use similar mathematical symbology, both for sentences in logic and sentences about logic. Wherever possible, we try to be clear about this distinction, but the potential for confusion remains. Unfortunately, this comes with the territory. We're using logic to study logic. It's our most powerful intellectual tool.